electrons, that virtually no mass, that negligible amount of mass. Remember, the electrons have some mass. It's just virtually none of it. It's sort of like when we go to the doctor and we get on the scale. Most of our body mass comes from everything that makes up our mass, our insides. I mean, yeah, my shirt and my bra and my pants and my shoes have some mass, but overall, my doctor is not concerned that I have clothes on, because every time I go to the doctor, I have clothes on, right? So the difference between today's outfit and next month's outfit is not hugely impactful to my doctor. Everything inside of me is what he's pissed about, not that I have on shorts today and pants next time.
Unless you have like 10 pounds of clothes.
Well, but I don't. So that's not really an issue for her. All right, we're going to talk naming the rest of the day. Okay? We did all the background notes yesterday. So today, Anae, put it on my desk. What?
Finishing the warm-up.
Get a calculator to do that then and not use your phone calculator. If you were going to finish the warm-up, you should have kept the calculator. The rest of us are not doing the warm-ups. Now, we're going to talk naming. We're going to start with writing formulas today because they are the easiest place to start. Now, we are also going to start with binary compounds. Now, binary means what from math class? It does. It means 2. So we're going to start with 2 elements. And I'm electing to only start with ionic compounds. So if I'm going to do ionic today and tomorrow, what kinds of elements are we starting with first? Yesterday. Metals and? All right. So we're going to start with 1 metal and 1 non-metal. By the time we leave class today, we will have branched out into 3 elements. And it will be literally right at the end of class that we will have made it into the 3s. But right now, we're going to start with 2 elements only. 1 will be a metal, and 1 will be a non-metal. Now, those of you who had a good experience in 8th grade with a real science teacher probably did this piece of writing formulas. Those of you who had a crappy experience probably didn't get this. Now, the steps to do this, we're only writing down 1 time because it will be the exact same steps when we get down here to number 4 and next week when we do covalent. The steps are all the same. Number 1, look up the symbols. Now, I always write that because in naming, there's no partial credit. If you write down the wrong symbol, your answer is wrong. If I tell you sodium and you write S, or you write SO instead of Na, your answer is wrong. If I say potassium and you write P, your answer is wrong. If I say chlorine and you write C instead of Cl, your answer is wrong. Fluorine is F, not FL. Your answer is wrong. There is no partial credit in naming. So if you're unsure, look up the symbols. That blue card I gave you yesterday has every element we're going to use, for the most part, listed on it, or you can find it on the periodic table. Will I ever deny you access to the periodic table in this classroom? No, because I already told you we're not memorizing it. It's stupid. Okay? I know teachers who still require that. It was stupid when I had to do it. It's still stupid today. Number 2, look up the oxidation numbers. Now, I told you yesterday that I'm one of those people who teaches this backwards. Lots of people make students memorize this information, or they spend 9 weeks teaching you how to find all this stuff, so when they get to it, you already know how to find all this junk. I teach you backwards. I'm giving you access to all the numbers now. We're going to learn the process, and then I'm going to teach you how to find all the numbers as we cruise through the course. Now, the positive oxidation number must be first, and the negative oxidation number is last. This will be important information in just a little bit. Number 3. This is the part you might remember if you had a good experience. We're going to crisscross the oxidation number only. Not the sign. Okay? The plus and the minus sign is not going to be used. That's only to tell us who's first and who's last. Okay? We crisscross the oxidation numbers only. And number 4, reduce when necessary. This is a little bit like math class. So if you get a fraction like 2 over 4 in math class, what would you do with a 2 over 4? You'd write 1/2. Well, if you get a subscript with a 2 and a 4 in it, you will reduce that to 1 and a 2, just like you would in math class. But those steps are the same steps we will use late in class when we talk about polyatomic ions. Everybody with me? Got what we need?
Yes.
Tell me when you got it, Cameron.
Yep.
Okay. So, suppose we want to write the formula for aluminum chloride. Now, when you look up aluminum, its symbol is what?
AO.
Now, in chemistry, when you write a 2-letter symbol, the first letter is capitalized, the second letter is lowercase. Okay? Everybody knows that, right? If it's a singular element, the letter is capitalized. Now, every year, I get somebody who writes this. Is that okay?
No.
No. Is this okay?
No.
No. Has to be a capital and a lowercase. If you need to. The desk, I know you're not walking. You got those, please?
Yeah.
Okay, I won't count that against you. Just take the vest though. You need tissue, it's over there in the corner so you don't drip on your clothes. Watch the cords though. All right, chloride is okay, chloride is chlorine.
CL.
Okay, it's Cl. Now, this is an ending we're going to talk about in just a second when we get to names, right there. Okay? Now, flip your card over to the bottom. Not sure your periodic table. Use the blue card today. You turn over to the very back, at the very bottom. All right, you see where it says common spellings of binary ions?
Yes.
Okay, there's some of the endings that we're going to put on these when we get down to the names in just a moment. So if you're confused over what the element is with the IDE ending, there's some of the spellings to help you for just a couple minutes, okay? So, any questions about the symbols?
No.
Okay, what's the oxidation number for aluminum? Oxidation number for aluminum. Y'all all stare at Miss Hathaway as she comes through. What's the oxidation number for aluminum? +3. All right, what's the oxidation number for chlorine? All right, why'd you pick -1? All right, stop with that as the first one. Go back to this rule right here that I wrote down. The positive oxidation number must be first, and the negative oxidation number is last, right? So when you look up chlorine, chlorine has -1, +1, +3, +5, and +7. It's -1 because it's last, so it has to be what?
Negative.
That's right. So it must be negative. It doesn't matter that it's written first on the sheet. That's irrelevant. All right, but because it's last in the formula, it has to be a negative oxidation number. So that's why we put the -1 on chlorine. Okay? So what now? We're going to talk about what it would be. But yes, chlorine, if it was first, would have to be positive. Now, which positive it would be, hold that question. We're going to get to that in a minute. Okay? That's right. So if chlorine was first, it would have to be positive. Now, which positive is what Anae just asked? Hold that question. We're going to talk about that in a minute. So, if we go to step 3, we crisscross the numbers, not the signs. The plus and the minuses don't matter. For all practical purposes, we can get rid of those. Okay? We crisscross only the numbers. So the 3 crisscrosses over here to the chlorine. The 1 crisscrosses over here to the aluminum. So when I rewrite this, Al has what subscript? In math class, do I write X to the first? No, so I'm not going to write the 1 on aluminum. Chlorine has a what? Then we write the 3 because that's not a 1. Questions?
That's it.
That's it. Are you with me? Okay. All we did was the 3 went here. So it's 3's on aluminum and it crisscrosses to chlorine. The 1 is on chlorine, so it crisscrosses to the aluminum. So when we rewrite it, it's just like math class. So if you have a exponent to the first in math, we don't write the 1 on the X. So we're going to do the same thing in science class. I'm not going to write the 1 on aluminum. Now, I'll be honest. Until we get going with this pretty good, if you need to write the 1 on aluminum, write the 1 if it makes you feel better. Okay? And then write the 3 on the chlorine. I will not count off. I will not write it. And after you do this for a few days, most of you won't need to write it either. Okay? You'll find that you'll take that off. Most of you probably by Monday. All right? So, if we do another one. Let's say we do, I don't know, let's do calcium oxide. All right? Calcium has what symbol?
CA.
Ca? What's its oxidation number while you're there? All right, +2. Oxide. Oxide is what? Oxygen. Right? What's oxygen's oxidation number? -2. Now, what do we do with the 2? Two crisscrosses over here, and this 2 crisscrosses over there. All right, so what do we get? Ca2, O2. Now, this is where step 4 comes in. What 2 subscripts do we get? 2's. Do these 2 subscripts have anything in common? They can be what?
1.
They can be reduced by 2. So since these can reduce, we have to reduce them. So if we reduce them by 2, this can be reduced by 2, and that can be reduced by 2. So we get CaO. Now, if you need to write Ca1O1, you can. Okay? I'm not going to write the ones, but if you need to write the ones, it's okay. Yes, ma'am. Can you what? Yes, you can. Questions? When you come back in, close the door, Riley. All right, can we talk about one that will explain the question I told Anae and Andy to hang on to? All right, so let's say that we have manganese. All right, manganese 7 bromide. Now, the first thing I want to point out to you, if you look at your blue sheet, find magnesium and manganese. All right, they're one under the other. Now, look at the spellings. They are often confused on a quiz and a test. Magnesium is Mg. Manganese is Mn. You see the difference in the spellings? Okay, so notice that this one is slightly different because I have this Roman numeral here. Okay, so manganese is Mn, right?
Yes.
What can you tell me about its oxidation number on that sheet?
2, 3, 4, 5, 6, 7.
And they're all what kind of numbers? They're all positive numbers. So all we know is this has to be a positive number, and the sheet has like 5 different positive numbers on it, right? So this is the first element's oxidation number, okay? That number that's in the parentheses, that is the Roman numeral, is always the first element's oxidation number. They have to give it to you when there's more than one option, okay? So on the sheet, manganese must have more than one option, and so they're telling you to use what number?
7.
They're telling you to use the 7. So we're going to put plus 7 at the top here for manganese. Okay? Because it says 7. Okay? Bromide is Br. So we're going to write Br for bromide. Now, when you look up bromide, what number does it have on the sheet? -1. Okay? Because again, it's got more than one number. So you're just going to look up on the sheet. And it's got a negative number. And we need a negative number, so we're going to pick up the negative. Now, all we have to do is what? So 7 comes down, 1 comes down, and we get Mn, Br, 7. Everybody feel okay about that?
Yes.
Okay, we're going to practice a little bit, then we're going to write names.
I got a question.
Sure.
So, is there ever going to be a time, let's say, they have manganese, that one?
Manganese.
Yeah, manganese. Do they have that in the end, the second one?
No.
That one hasn't?
Well, they're going to have polyatomic ions that might have it where it's in the middle, yes. At the very end, no.
Yeah, because I was wondering if it's all positive, we have to switch that to the negative.
No, but it could be in the mid. So it could have like something at the front, and then Mn could be the middle element, and then something else negative at the end. Oh, I gave you one?
Yeah.
Okay. Yes, Karen.
Why do the negative turn positive?
That is the lab that we're going to do tomorrow. So hold that question to tomorrow. We're going to cut, glue, and paste tomorrow to explain that very answer. All right? Yeah, I know. It's going to be fascinating. You're going to think you're back in elementary school. Now, if you will, on the sheet, I want to do 1 through 8 at the top. This is divided into sections to go with our lessons, and I'll work ahead. 1 through 8. Some of you will get all 1 through 8 done before I call out the answers. Some of you might not quite get there. Okay, 1 through 8. Thank you, my dear. Do you want me to put your calculator up since you got it done? Good idea.
We always have to put the positive and negative.
So what now?
We always have to put positive and negative.
You don't. I don't care if you write it down or don't. Doesn't make any difference to me. As long as you got the numbers and you know which one's first and which one's last. September 27th. All right, who's got a question? Yes. All right, well, now put a negative sign down there.
What is that?
What is it? No. Where'd you get a 7 from? Fluorine.
No.
Okay, fluorine has what oxidation number? Fluorine is here. It's second, so it has to be a -1. So this would be a 1. So you're gonna have a 1 there. Okay?
Yeah.
All right, do another one. Where's that 7 coming from? Okay. Just like this, where's that 6 coming from? Where are you getting those numbers from? Yes, that's right. You gotta pick the -2 because where's sulfur in the formula? Is it first or is it last? That's right. So since it's last, it has to be a negative oxidation number. So you need to pick up a -2 in the formula. So if we go back to chlorine, chlorine is last. So what number should you have picked up from chlorine? There you go. Go back and fix this. Because you're crisscrossing them right, you just picked up the wrong numbers. All right, you switch the whole formula around. Put AL first and S. Yes, you're fine. You're fine. You did the same thing I did. What is it? Side of the rooms needs an exorcism. You switched NI and F, where you were F first and NI last. Flip it. NI still has to stay first because that's the metal. Yeah, you're fine. And you only did it on one, just like you did. Yeah, you're fine. All right, what you got, Brandon? Let's see what you got now. Much better, much better. Keep going. Good. We haven't done those. You don't know how to write names. All those are wrong. Stop. Y'all stop at 8 before you only get an A and write them wrong. These are designed to go with the lesson. Use your pencil so you can erase. Yes. All right, go back to N. Everything else is looking okay, except for this 7 that you're fixing right now, so, okay. All right, finish up the one you're on. Like I said, you may not get them all done. Grab a paper, because when it was loud when I called these out during the first period. All right, number 1 should be NaF. If you don't have them done, don't just write the answers down. Just check the ones you did. Number 1, NaF. Number 2, MgCl2. Number 3, Al2S3. Number 4, NiF2. I jumped one, didn't I? Which one did I skip?
Yes, good. You did.
Okay, I thought I jumped one. Number 5, Cr3N2. Number 6, Cu2O. 7, ZnI2. And 8, CaBr2. Questions about any of those you did? All right, let's talk about naming. Yes,
So,
I didn't see your hand. Yes.
What was 5 again?
5 is Cr3N2. No, I didn't. I said it wrong. Cr3N2. I flipped it in my head. Cr with a 3, N with a 2. All right, so when you look up chromium,
Yeah.
it's got what Roman numeral right beside it? All right, so Cr. Oh, boy. Cr has a 2 at the top of it. Nitrogen has what negative oxidation number beside it? Okay, so we're going to put a 3 up there. I'm not even going to write the negative and the positive. Okay, so the 3 comes down, and then the 2 comes down. So you get Cr3 and 2. Say what now? No, the Roman numeral is the first element's oxidation number. It does not say read the second element on the chart or pick the second element or anything like that. It means this element right here is a +2.
Will the second element ever have a Roman numeral?
No, it will not. Never, ever. I mean, let me say this. Yes, it can. It will not in this class. Okay? And it will come as part of the polyatomic ion's name. But for our class, no. So let me qualify that. Cameron, you still with me?
yeah.
Okay. All right, so let's write names. Now, again, we're talking what kind of compounds? All right, ionic and binary. Because tomorrow, we're going to write names for polyatomic ions. We're going to do this part tomorrow before we do our cutting and gluing. So, when we say binary, binary means 2 elements. So, step number 1, name the first element. Number 2, name the second element. And add an IDE ending. Okay, now the reason I made sure that I pointed out that we were talking about binary is because we only add an IDE ending if we're talking about what kind of compounds? Binary. Okay, we don't add this IDE ending for anything except binary. So you have to have 2 elements to add an IDE ending. Now, if you remember yesterday, I told you, I gave you these spellings for those of you who are spelling challenged. So, if you don't know how to spell it when you add the IDE ending, I put them here on the back of the sheet so that I didn't get some god-awful jacked up mess with the IDE ending. Now, if you come close and you have a missing I, or you messed up one vowel or something, no, I'm not going to mark the whole question wrong. But if you completely mess up nitride or oxide or sulfide, yeah, you got a good chance of getting the question wrong. So make sure you look up the spelling if you don't know how to do it right. Now, step 4 is where the problem usually comes in. All right, or sorry, step 3, sorry. I meant to say 3, not 4. I'm getting old and forgetful, and it's the end of the day. All right, so step 4. Check the first elements. I know. I was hoping y'all wouldn't catch that twice. Check the first element's oxidation number. Now, y'all could just pretend that I didn't say it twice and be nice to me. check the first element's oxidation number. If there is only one number, no Roman numeral. If more than one number listed must include a Roman number. All right, so we have to check that first element to decide if we need a Roman numeral. That's what we got to figure out, okay? It comes from the formula. But if I tell you all that and that, you're going to think step 3 never ends. So we'll figure that out in the examples. All right, so you're going to check the first element's oxidation number. If there's only one number listed on the sheet, then you don't have one. But if there's more than one, then we're going to need a Roman numeral. Now, we're going to talk about how to find that Roman numeral, like I just told Danae, rather than me listing all of that in step 3, or step 3 is never going to end. Is everybody caught up? Cameron, you got it? Okay, I just wanted to make sure you weren't writing that and you were writing something else. All right, so why do we have step 3? Step 3 comes in for compounds like this. Can we agree that those are 2 different compounds? Yes. Okay. Well, if we just write step 1 and step 2, what's the name of Cu? You can look at your chart if you don't know. Copper. Okay. So we'll write copper for both of them. All right. What's the name of Cl? Chlorine. Is this binary? So we add what? IDE. So chloride. So if we write copper chloride, what can you tell me about those 2 names? They're the same. So how can we name both of them the same, but they're 2 different compounds? Is that going to work for us?
No.
No. So that's why we have step 3. Okay? So I need you to look up copper. Copper has how many numbers listed on the sheet?
2.
Okay. Now, I tried to do this in first period one way. I didn't get it. So we're going to try it the way they did get it. Everybody catch up with me and get your blue sheet out so you can see. All right, we all caught up?
Yes.
Find your blue sheet. All right, look at the front side. Find the first element, which is aluminum. Tell me how many numbers are listed beside aluminum.
1.
1. That number is +3. So every formula that aluminum has will only ever have what oxidation number? +3. Because there's only one number listed on the sheet. Will I ever need to use a Roman numeral?
No.
No, because it only has one number. Now, the next element on there is antimony. How many numbers are listed on that sheet beside antimony? 3. So when I look on that sheet and I see 3 numbers listed, I need to always use a what in the name? A Roman numeral, because there's 3 numbers listed on that sheet. Okay? The next element says arsenic. How many numbers are listed on that sheet for arsenic? 3. I'm going to have to use a what every time? A Roman numeral.
So there's more than one Roman numeral. There's just one.
Okay, so barium has how many numbers listed on the sheet?
1.
Will it need a Roman numeral?
No.
No. Okay, a lot of times people tell me, oh, it's got a 2, Miss Wall, it's got 2 numbers listed there. The 2 is not 2 numbers. The +2 is how many numbers? It's only one number. Okay? One number means there's no Roman numeral. All right, so when you looked up copper, copper had how many numbers listed there? 2. That tells me that I have to use a Roman numeral beside copper in each of those names. Now, the Roman numeral itself, this comes from the formula. Okay? It comes from the formula. I have to backwards crisscross to figure out what the number used to be. So I take my subscripts. There are no subscripts here, right?
No.
So they were ones. This 1 came from copper. So copper used to be a +1, right? So I put a Roman numeral 1 right there. Now, students will often say, Miss Wall, it's a 1. Do I actually have to write the 1 in the Roman numeral? This is the one time that, yes, you have to write the 1. Because if it's a Roman numeral of 1, you need to tell me the oxidation number is a 1, Miss Wall. I won't assume that it's a 1. Now, in this formula, what number came from the copper?
2.
So you put Roman numeral 2 there. So this was copper 1 chloride, and that's copper 2 chloride. That's how we tell the difference between the two names. Are you with me?
Yes.
Okay. Now, so that no one is embarrassed, in case you don't know your Roman numerals. Does everybody have any off the board?
Yes.
All right. You only have to know Roman numerals 1, 2, 3. Make sure I actually draw the V so it's legible this time. 4, 5, 6, and 7. Those are the only Roman numerals we will use with the stock system. So if you don't know those 7, put them in your notes so you do know them. Remember what I said about partial credit. Is there any?
No.
No. So if you get them backwards, it's just wrong. Okay? Which one do you think more people get wrong than anything else?
4.
The 4 and the 6. The 4 is the one we get wrong 9 times out of 10, but the 4 and the 6 are the ones that are usually backwards. So make sure you know those when you need them. And we will be learning the prefixes 1 through 10 when we do the old system. But these will be the most we need in Roman numerals, is 1 through 7. So that's late next week. And you're working with these and you get a Roman numeral of 9. What should that tell you?
You're wrong.
You should. But you'd be surprised how many people will give me some weird answers on the test. They think I'm tricking them. Giving them something that I hadn't given them and I'm giving them an extension question. I promise you, I don't do that to you on the test. Oops, we're writing names, not giving you the name. Blah, 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 blah. All right, let's say we want to write that. Let's write his name. All right, what is K? All right, we write potassium. Potassium. What is P? All right, it's phosphorus. Now, is this binary? And what does binary mean? So is it binary? So what ending are we going to add on it? IDE. So do we know how to spell phosphorus added with an IDE? Fluoride. You done changed the element altogether. You hanging out with first period. Phosphide. PHOSPHIDE would be how we change phosphorus into phosphide. Okay? So phosphide. Now, what's the last step? Do we need a Roman numeral?
Yes.
All right. Look up potassium. How many numbers do you see beside potassium?
1.
Do we need a Roman numeral if there's one number?
No.
No. We only need a Roman numeral if there's 2 or more. On that first, you're only worried about the first element. Phosphorus doesn't matter.
Okay.
You are only looking up K. You were looking up this dude. And he only has how many numbers written out there?
1.
No Roman numeral. Okay? We'll do one more before we talk about polyatomic ions because I'm going to give you homework with this. Yes, stop whining. It's non-negotiable.
What are you doing? But if I give you $1.
I'm not that poor.
I'll make you 3.
Still not that poor. AS2O5. All right. What's AS?
Arsenic.
Arsenic. Okay. What's O? All right. So what do we do to oxygen? Oxide. Do we know how to spell oxide? O-X-I-D-E. All right. Phosphide was just an oddball one I gave you to see if you could do, but oxide is on the back side if you don't know how to spell it so that you can get that one right. Okay. Now, how do we decide if, excuse me, I need a Roman numeral. From which one? The O or the S?
Oh. Hey, wait. Wait, what'd you say?
Which one tells us we need a Roman numeral?
The first one.
The first one. So we're looking up the what?
It's arsenic.
Arsenic.
I thought you
All
meant.
right.
I thought you meant.
Oh, you're just talking about what Roman numeral?
Yeah.
Okay, you're ahead of me. I got you. So we look up AS. How many numbers does AS have on the sheet? All right, so it's got a -3, a +3, and a +5, if I'm not mistaken. All right, so that tells us we need a what? Gonna have to have a Roman numeral. Now, what Roman numeral am I gonna have? I'm gonna have a 5. Everybody with us on how to do that? Okay, because this 5 came from there, and that 2 came from there. Not yet. Got to talk about polyatomic ions. All right, you with me? Okay, we'll practice that for homework. Now, formulas with polyatomic ions. At least y'all are quiet. Last spring's class, they didn't get this far, and I had to constantly send them to watch YouTube to get the end of class. I hated it. Because then stuff would be on the quiz the next day. They're like, you didn't teach that? Yeah, I did. 3rd period. Watch it on YouTube. Now, writing a polyatomic ion with a formula works just like what we practiced a couple minutes ago. We're only going to add in one tiny little new piece. Suppose we want to write the formula of iron 3 sulfate. What tells you that this, first of all, has a polyatomic ion in it? How do you know? We have Roman numerals in the binary compounds. How do you know that is not binary and has a polyatomic ion? What's different about that name?
Oh, it's located.
Huh? What? What about the IDE? It doesn't have it. It says 8, right? Okay. So, Anae said there's no IDE. It says ATE. This is what tells you this is a polyatomic ion. Binary compounds all ended in what? IDE. This doesn't end in IDE. It ends in ATE. That tells you it's a polyatomic ion. Okay? Now, the polyatomic ions are again in these 2 columns right here on your sheet. So the process is the same. What is iron's symbol? Good. What is iron's oxidation number?
3.
Why are y'all looking down there and not up here at me? Y'all crack me up with this. First period did the same thing. Y'all are all looking at those blue cards.
3.
What is this right here?
The Roman numeral.
This Roman numeral right here tells you the oxidation number of the first element. And y'all are all studying the cards, looking for the oxidation number of iron. I told you the oxidation number when I give you the Roman numeral. Don't feel bad. Every chemistry class every year does it. Y'all will still be doing it for a couple days. Looking at those cards like they're the Holy Grail. Okay? The Roman numeral right there tells you that iron is a +3. Now, what is sulfate? Now, that's a polyatomic ion. Where did I tell you the polyatomic ions were? S. Look at your polyatomic ion column. Find sulfate. All right, you geniuses.
SO4.
Now, some of y'all still looking at the back side.
Yeah.
Right here. How many times I gotta show y'all this? 2 columns, right here. One is the name, one is the formula column, right here.
Okay.
Everybody see those? Stop looking at the back side.
How come for the letters, just looking, one of them, both of them are capital and not the other letters?
Because they're 2 different elements. Yes, it's more than one atom combined. Okay? So what is the formula for sulfate?
SO4.
SO4.
-2.
And what is its oxidation number? -2. Now, this is the only new step, other than for some of y'all finding it on the chart. Take parentheses and put it around the polyatomic ion. What did I not put inside the parentheses? The oxidation number, because what am I going to have to do with the oxidation number? Don't have to crisscross it, right? So it's got to stay outside. That SO4 is sacred. It's the Holy Grail. Cannot touch it. You can't touch the S, the O, or the 4. The only thing we can move is the 3 and the 2. Okay? So, this 3 is going all the way over here. This 2 is going all the way over here. I can't touch that SO4, so it's got to travel all the way to the other side. All the way to the other side. Now, all I have to do is rewrite it. FE
Good afternoon, students.
has what subscript?
I'm sorry for the interruption. We need to make a correction.
Parentheses.
For the junior class officers.
SO.
President will be Mary Lloyd
4.
Callicut. Vice President will be Jaden Bates. Secretary Melissa Sauer. And Treasurer Karen Lim. Thank you.
Who did they say earlier?
That's the change treasurer.
Oh, okay. So FE2 parentheses SO4 close the parentheses 3. Okay? Now, questions?
So you still have to put the parentheses.
Yes, you have to put the parentheses. What's the only time you would not need the parentheses? If this number out here was a what? A 1, you could leave them off. But if it's not a 1, you can't leave them off. All right, you got your sheet handy? All right. We're going to do 9 through 19 on this side. 9 through 19. Down here at the bottom. Because we learned how to write names. And on the back, the top half. 1 through 9. We have not learned how to write the names of polyatomic ions. So don't work those yet. We're going to do those tomorrow before we cut, glue, and paste. Okay? Tomorrow we're going to spend 60 minutes cut, glue, and paste. For the back, the top half. Okay. Okay? Tomorrow you will only get 60 minutes to cut, glue, and paste. So if you cut, glue, and paste slowly, when do you finish it?
At home.
No.
After school.
If you make me stay late on a Friday, I'm going to be pissy.
Monday.
No. There is no Monday. There's no Sunday.
Just Wednesday.
Got to be done tomorrow.